So we've just finished part B of our rock launched from the surface of the moon problem, and we are now in this video moving on to part C, which says, how long does it take for the rock to reach its maximum height? And again, we are given these initial values here, some of which were given to us, and most of which now we've solved for in the previous parts, including our two new values of the initial y direction velocity, 4.025 meters per second, and our final y direction velocity at the top of our rock's trajectory right here. And then we are also given the kinematic equations, which we wrote down in part B, now rewritten for us to use in this part again. So right off the bat, we should recognize that our problem is asking us for a time that we ignored in the previous part because we were not looking for time at all and time was not given to us. So we couldn't use these two kinematic equations to solve for our initial y direction velocity. But now we are being asked for the time that it takes to go from our initial point of launch up to the 5-meter height. So that means, unlike the previous part where we used this kinematic equation, we can automatically rule this one out because we cannot possibly solve for time using this kinematic equation if time is not a variable in it. So that leaves us with the two other kinematic equations, with both of which have time included as a variable, but in reality, both of these can be used to help us solve for time because we have all of the information needed to solve for time. We have the final distance and the initial distance, the initial y direction velocity, and acceleration, the final velocity, initial velocity, and acceleration. But now we just have to recognize which kinematic equation is easier to use to solve for time. And we can probably tell it would be the first equation here, because the second equation is in quadratic form, and we really want to avoid using the ever infamous quadratic formula to solve for time. So just for simplicity's sake, again, we're going to rule out this kinematic equation, even though we could validly use it to solve for time. And we are just going to take this kinematic equation and bring it down here and put it into terms of the y direction. So we have the final y direction velocity is equal to the initial y direction velocity plus acceleration due to gravity times time. And again, now it's just a matter of filling in our variables because we know our final y direction velocity is 0 meters per second and our initial y direction velocity is 4.025 meters per second. And of course we have our acceleration due to gravity on the moon. So now we just need to plug these in, and we have that 0 is equal to 4.025 plus negative 1.62 times time. And then once again, just basic algebra, bringing over, we can add 1.62 times time on both sides just to make it positive, equal to 4.025. And then we just divide by 1.62 on both sides and calculate this. And we find that our time to reach maximum height is equal to 2.48 seconds. So just to highlight what this looks like, we can just go to our diagram here, and we know that this time was from this initial point up to where the rock reaches its maximum height. And that is the time that we just solved for, 2.48 seconds.